Let's talk about something called weak acid ionization. So before we get into that, let's just remember what we know about weak acids. So first, let's start with what we know about strong acids. So strong acids ionize completely. So if we had a strong acid, like for example HCl, it would break apart into a hydrogen ion and a chloride ion. So that's aqueous, that's aqueous, that's aqueous. Okay, this is 100% ionization, which means there's no more HCl left after this reaction happens because all of it has broken apart. This is not in equilibrium because it ionizes completely. So there's no equilibrium chemistry for strong acids. Weak acids ionize partially. And the degree to which they ionize is different for every weak acid. The generic term for a weak acid is HA, and when it combines with water, liquid, it is in equilibrium with the products, which is A minus aqueous plus H3O plus aqueous. So this is acid-base chemistry. These are the conjugate base pairs. Remember, this is always just the transfer of a hydrogen. This is the acid. It's acting like an acid because it is losing a hydrogen. This is the base. It's acting like a base because it is accepting a hydrogen. So everything that we know about acid-base chemistry is the same. Strong acids ionize completely. There's no equilibrium chemistry. Because weak acids ionize partially, they exist in equilibrium. Which means everything we know about chemical equilibrium applies to weak acid chemistry. So when we were talking about equilibrium before, we said there was the Kc. The Kc was for concentration. When we have weak acids, we have what's called the Ka. And the Ka is the acid ionization constant. And this tells us the degree to which a acid is going to break apart. So the higher the Ka, the stronger the acid, because that means more H3O plus produced. So when I say the stronger the acid, it's still a weak acid, but you can rank weak acids based on their Kas. Kas that are bigger numbers would have more of this hydronium produced, which would make it have a lower pH, which is the measure of how strong or weak an acid is. So let's write the Ka. I'm going to write the Ka from my weak acid ionization. Actually, I'll write the weak acid ionization again over here. So I'll write HA aqueous plus water liquid is in equilibrium with A minus aqueous plus hydronium aqueous. And again, the order of these don't matter. The conjugate base of the weak acid and the hydronium, those could be flipped. It doesn't matter. So remember what the Ka is. The Ka is the concentration of the products over the concentration of the reactants. Remember, all the same rules apply. Coefficients become exponents, and pure substances are excluded. So if you were to write the Ka here, I would say Ka equals the concentration of the products, A minus, times concentration of hydronium over HA. And that's it, right? Because this water is a pure substance, so it is excluded. You also could see it written as just a 1 here, that 1 representing the water, but that's unnecessary. So essentially what this Ka is telling you is this is how much of the acid ionized. Ionized is just a chemistry way of saying broke apart into into ions. And this Ha is how much of the acid stayed together. So you'll see the bigger this Ka number is, that means the numerator is larger. The larger the numerator, that means more of this acid broke apart. And remember, acid strength, or the way that we measure acids with pH, has to do with the concentration of hydronium. So the bigger the Ka, the more hydronium that there is, the lower the pH, the stronger the acid. Ranking strengths of weak acids does not make it a strong acid. All of these weak acids are weak because remember, we define being weak and strong having to do with their ionization being completely 100% or partially and existing in equilibrium. So every weak acid has its own Ka. Every single weak acid, you are not responsible for knowing what the weak acids are because there are hundreds of them. You need to know the 6 strong acids, and then you know every acid that is not a strong acid is a weak acid. Also, another way that you can tell if an acid is a weak acid is if a Ka is given. A Ka is an equilibrium constant. You would only ever get an equilibrium constant for a weak acid which exists in equilibrium, never for a strong acid because they do not exist in equilibrium. So let's just take a second and rank some weak acids based on their Kas. So here is the Ka, and here is the weak acid. So let's say hydrofluoric acid has a Ka of 6.8 times 10 to the negative 4th. Nitrous acid, HNO2, not HNO3. HNO3 is nitric acid. HNO2 is nitrous acid. There's a difference. 4.5 times 10 to the negative 4. Acetic acid. And cyanic acid. So if we were to rank these from most acidic to least acidic, I accidentally wrote them in descending order. So this is the most acidic because it has the largest Ka. 6.8 times 10 to the negative 4th is the largest number out of these 4 numbers. So this, I would say, is the most acidic. The next acidic would be this one because that's the second highest number. That's the third highest number. This is the 4th, the lowest number. This would be the least acidic because it has the smallest Ka. And remember, the Ka is just a ratio of how much broke apart to how much stayed together. The more the acid breaks apart, the more hydronium ion is produced, the lower the pH, the stronger the acid. So I would expect you to be able to rank weak acids. You are not responsible for knowing the names or the formulas of any of the weak acids because there are so many. You are responsible for the strong acids and recognizing that these are not strong acids, which means they must be weak acids. Also, anytime you're given a Ka, that is a signal that this is a weak acid because only weak acids exist in equilibrium, and the Ka is just the equilibrium constant for this specific example of weak acids.